Have you ever faced a math problem that just felt impossible? We're about to look at one that stumped the greatest minds for centuries. And the solution? Well, what if you didn't have to find it, but you could invent it? Let's dive in.
So, really, what do you do when you hit a wall like that? For hundreds of years, mathematicians kept running into this one specific problem, an equation that just seemed to have no answer. A real dead end. Yeah, they were totally stuck. You had these equations that looked pretty simple on the surface, but the results they were spitting out, they just made no sense at all. The answers didn't fit anywhere on the number line we all know and love.
And here's the big one, the heart of the whole problem, trying to find the square root of a negative number. Like, what's the square root of -1? If you think about that number line from school, there's just nothing, no answer. It was basically considered impossible.
Let's quickly break down why this was such a headache, right? Think about it. A positive number squared is positive. 2 times 2 is 4. But a negative number squared, well, that's also positive. -2 times -2 is still 4. So there was just no real number you could multiply by itself to get a negative number. It just couldn't be done. So what do you do when the rules just don't work? Well, you don't give up. You make new rules. And that's exactly what happened. Mathematicians got super creative and literally forged a key to unlock a whole secret dimension of math. And I mean that literally. They didn't discover this solution somewhere. It wasn't hiding under a rock. They created it. They built a brand new tool from scratch, designed for one purpose, to solve this impossible problem.
And here it is. Meet the imaginary unit, I. The definition is so simple, it's kind of beautiful. I is the square root of -1. That's it. It was created to do the one thing no other number could do.
Now, this is the really crucial part. If I is the square root of -1, that means if you square it, if you do I times I, you have to get -1. And that one little fact, that's the engine that's going to drive everything we do from here on out. Okay, so we've got this awesome new tool, I. What do we do with it? Well, we don't just throw out all the old numbers. Nope, we combine them. And this combination, this fusion of the old and the new, creates a whole new category of numbers called complex numbers.
And this is what a complex number looks like. Pretty straightforward, right? It's got 2 parts. You've got A, which is just a regular old real number from the number line, and then you have the BI part. That's the imaginary part. It's just another real number, but it's attached to our new tool, I. Super simple, but wow, is it powerful.
All right, enough theory. Theory's great, but let's see this thing actually work. We're going to take one of those unsolvable equations and see how I lets us just crack it wide open. Okay, here's our target. Looks like a pretty normal quadratic equation, doesn't it? But here's the catch. If you were to graph this thing, the curve would never actually touch the x-axis. That means no real solutions. And in the olden days, this is where you just have to stop. So let's pull out the good old quadratic formula. We grab our a, b, and c, plug them in. We start simplifying what's under that square root sign. You get 4 minus 8, which leaves us with the square root of -4. And we're stuck. We're right back at that same old dead end.
And this is it. This is the moment of truth. Before, this is where you just write no solution and move on with your life. But now we have our key.
Okay, watch this. This is the magic trick. We can take that square root of -4 and just split it apart. We can rewrite it as the square root of 4 times the square root of -1. Now, we know the square root of 4 is just 2, and we defined the square root of -1 as I. So that impossible square root of -4 just becomes 2i. Boom, problem solved. So now that we've cleared that roadblock, we can just take our 2i and pop it right back into the formula where the square root of -4 used to be. The path to the answer is wide open. So now our equation looks like this. X equals -2 plus or minus 2i, all of that over 2. We are so close now. And after one last little bit of simplifying, we get our answers. And not just one, but 2 of them. X equals -1 plus I, and X equals -1 minus I. We just found 2 perfectly valid, complex solutions to a problem that used to be impossible. So what's the big deal here? I mean, this isn't just a neat party trick for solving one type of equation. This was a massive shift,
a fundamental change in how we even think about what numbers are.
It was like a whole new dimension of math was unlocked. We went from this flat, one-dimensional number line to this huge, two-dimensional space where numbers could have both a real part and an imaginary part. And that leap, wow, it opened the door for entire new fields of science and engineering.
Think about it. By having the guts to just invent a tool to solve an impossible problem, they gave us a whole new language, a language we absolutely need to describe the world around us. I'm talking everything from electrical engineering to the really weird rules of quantum mechanics.
And that just leaves you with a really cool thought, doesn't it? This whole journey started because someone refused to accept a dead end. So it makes you wonder, what problems that we think are impossible today are just waiting for someone to invent one clever new tool to unlock everything?